Welcome back, everyone. Let's look at the Now You Try problem for solving equations and inequalities graphically using GeoGebra. Here, for the first problem that we're looking at, we have functions h of x equals negative 10x squared minus 5x plus 3, and j of x equals negative 3x minus 9, and we want to use GeoGebra to help us get through these. Create a little more space, whoops. I just realized in that last one we didn't have enough space. Should have done this beforehand. I know. There we go. Okay. Let's get GeoGebra out and we'll go ahead and clear out what I had for the previous problem. Now we're going to enter in these functions. We have h of x equals negative 10x to the second minus 5x plus 3. And we have j of x equals negative 3x minus 9. All right, so we want to really key in on the intersections of these two functions here. Get a nice viewing window where we can see those. Go ahead and type in intersect of h comma j. And then I can see them listed here in that menu. I like switching and putting them on the graph itself. It's helpful for just how I like to think about things. And then I'll take a screenshot of that to reference and then plop it down in my worksheet. Here we've got our graph that we just made. And bring this over, shrink it down just a little bit. There we go. All right, let's look at this and answer some questions. Let's start by answering part A, the points of intersection of the two functions. So we've got those listed here. Our first one is negative 1.2 comma negative 5.4. The second one is 1 comma negative 12. So if we're looking for solving h of x equals j of x, we can say the solution set is the set containing the numbers negative 1.2 and the number 1. And we know that because if x is either of those values, then the outputs of both functions will, well, if x is negative 1.2, then both functions will output negative 5.4. So that's where the two functions are equal to each other in their outputs. For that x value, we'll get the same outputs in both. If x is 1, both functions output negative 12. So 1 is also a solution to h of x equals j of x. Where are the two functions equal in their outputs? Remember, h of x means output. J of x is the output of j when you input a given x value. Now we want to solve where is h of x greater than or equal to j of x. Let's note that h of x is the purple line here. There we go. J of x is the gray line. I'm having issues with this. I don't know why it's... still purple. And if I do this and then go... It's so weird, it's not letting me change colors very easily at all. Wonder. Alright, hang tight. I'm going to pause the video. I think the battery's dying on my stylus. J of x is the gray line. Well, I think I got it working at least for now. Okay. J of x is the gray line, so we want the purple line to be above or equal to, so we can include the endpoints. We want to know when are the y values of the purple line greater than the y values of the gray line. So when are they above the y values of the gray line? We can see that that happens in this green shaded region when x is, this is when, so h is greater than or equal to j when x is between negative 1.2 and positive 1. So we can say the interval of solutions is interval from negative 1.2 to positive 1, where we get to include the endpoints, so we'll use square brackets on that. All right, next we want to know where is h of x less than j of x. So that's where the purple line is under the gray line. You can see that in the yellow shaded region to when x is, so h is less than j out to the left here, when x is less than negative 1.2. And to the right, we see that h is less than j. The purple line's under the gray line when x is greater than positive 1. And there we do not include those endpoints because there's no equality here that we want in the inequality. So that h of x is strictly less than j of x. So we can say the interval of solutions is negative infinity to negative 1.2 unioned with 1 to infinity, all the numbers that are less than negative 1.2 along with all the numbers from 1 to infinity, all the numbers greater than 1. I like using the union symbol to read as along with that interval. It's a nice way of interpreting it, a little bit more regular words instead of formal words in math. All right, let's move on to number 2. Here, we're not given the function initially. We're just given an equation and an inequality and then asked to solve these, where we're going to use GeoGebra to help us. So for part A, we have the equation 150x squared minus 20x plus 50 equals 100x plus 40. So we're going to let f of x equal the left side, 150x squared minus 20x plus 50, and g of x we're going to have equal the right side of the equation, 100x plus 40. So pull up the calculator, we'll go ahead and start anew here. And I'm going to type in f of x equals 150 x to the second, get out of that exponent, minus 20x plus 50, and then g of x equals 100x plus 40. And where did that green line go now? Oh, there's some green up there. Zoom around, sliding with my fingers until I can get a picture of that. And I'll get the intersections of f and g. Hit enter, and again, I'll click on these and switch them from label to value. So turn off label, turn on value. This seems to be more helpful. All right, and then we'll take a screenshot. Plop that in over here. And so we can see that the x values of these 2 points are when the outputs of both the left side and the right side are going to be the same. So we can say the solution set is the set of x values such that x is approximately 0.09 and 0.71, rounding up from that 5 to the right there. And that's because those are the two x values of the intersection points, because those x values will produce the same output for both functions, which are the left side and the right side of the equation. We want both the left and right side of the equation to output the same thing, so we've used graphs to find the x values where that occurs. All right, let's look at part B, where we're looking at solving an inequality. And get some graphs going, start over again. Let's let f of x equal negative 10 x to the second minus 15x plus 4, and g of x equal to 9. Oops, 9 there. And let's see if we can slide around. There we go. That's not too bad. Maybe stretch it a little bit this way. Get the intersections. Intersect f and g, and there we go. And let's plot this in. Ooh, so big. Bring it back down to size. There we go. All right, I wanted to write in, I didn't do this before, and I should have, that f of x equals negative 10x squared minus 15x plus 4, and g of x equals 9. Let those two things, we're defining those. Goodness. All right, so we see that we want the f is the green line. This is green. My pen's partially working. We're so close to being done. Just want to get through this. Sorry. Oh, it's mad at me. And I can't figure out why. Okay. So f is the green line, and we want that to be underneath I had to pause the video and fix that. It was bothering me. Okay, so we wanted the green line underneath the blue line. I made f of x green and g of x blue there. And so since the equation calls, or sorry, not equation, the inequality calls for the green line to be less than or equal to the blue line, we want to look at where we have this yellow highlighted here, where the x values are less than -1, less than or equal to -1, because the inequality does allow for them to be equal to each other, or where x is greater than or equal to -0.5. So we can say the interval of solutions is from -infinity up to -1 inclusive, along with the numbers greater than or equal to -0.5, so including that up to infinity. And that's it. That's everything. We've got this finished. I managed to stretch this battery out. I'll have to replace it here after I'm done. Thank you so much for watching, everyone. That concludes this module, and we will see you next class. Thank you so much. Have a great day. Bye-bye.